Hello friends, I am Naren, your friend and your host, and I am back with another video. In this video we're gonna talk about loops, expression and function in Terraform. So let's get started to understand loop, expression and function. Loops. Terraform Terraform does not have traditional for or while loops like programming language. Instead, it provides a special looping construct. First one is count. The count is used to create multiple instances of a resource, and it can be accessed via count.index. So this is very useful when you have you are planning to create multiple objects or multiple resource with the same configuration but a minor difference, like for example multiple instance with all the same configuration except the instance name. Okay, so you can go for the count. Next one we have for each. For each is used to iterate over a map or set of string. It's technically more like a for each loop in other functional programming language. Create one resource per key value pair. Of course, at the end of the video we will going to see a demo all about all loops and expression and function. So just understand that we do have count and for each, and there is for expression. This is not a loop but it's more like an expression support by Terraform, where you can use this for expression and retrieve some value from the map or set of strings. We will of course we will see the demo at the end of this video. And then at last we have the dynamic blocks. This is very useful block in the Terragrant. It's repeating nested block. We will see a demo after this PPT. Expression allow computation or transformation value. Expression is nothing but when you sometime like in other programming language we are doing some like a plus b. This is nothing but expression, or we are interpolation the strings like string abc plus bcd. So we can something like this kind of call the expression. So Terraform also support this kind of expression. So let's see, we have a string interpolation. Of course you can combine two string or do the string manipulation dynamically or statically. And then we have conditional expression, where you can use like a ternary operator question and then the condition question and then true value and colon false value, something like that. And we also support the arithmetic operation like plus minus and division, all the arithmetic operation that you will do the numeric value. And we also support logical operator like more like a logical expression, like we have double ampersand, not and pipe sign. So if you are familiar with other programming language, then you might familiar with this logical operator and how it can be used in the expression to getting something, some kind of comparison. Okay, so we have, apart from that loops expression, Terraform has so many lots of inbuilt functions like you can have a string function. Of course I will show you how you can find multiple function based on your requirement from the Terraform documentation. Of course we will also learn how we can using a function in the Terraform. Then we have numeric functions, then we have collection functions, and then we have encode and file systems. And there are few many, I mean a lot of functions are supported by Terraform inbuilt. And okay, so let's go to the demo section. So I will open my command prompt. In the command prompt we can go to see the loops. I created the folder loops expression in function. Go here, let's open our Visual Studio Code. By running the command code dot, it will help us to open a Visual Studio Code if you installs. So we have a readme files here. In this readme files I given an example for each and loop, so we can, let's try to create a new file that we can say main.tf. In this, let's use the count first. We can say count, and then I will, let's create the AW first. Before creating the AWS, we can AWS resource, we can have a provider, probably provider AWS, and we want to give the region equal to we want the region in US East 01, not 01, just 1. And then I think Terraform block is not needed here. It will be automatically downloaded the latest plugin if you not specified. But if you want to specify, better let's specify, so it will be very clear. So you can add the Terraform block here. In the Terraform block required version, we have the required provider, I believe, and then we can say AWS equal to source, from where you want to get this module. I want to get it HashiCorp slash AW1, and then we also need to specify version, and I'm putting in this quotation mark, so 5.0, whatever the higher version or latest version over the 5.0 should be downloaded. So now the pre-configuration has been done. So now let's going to use the count part. We can copy the comment from here and can write it down below here in the sense. So what we can going to do, we can saying resource, and we're saying AWS instance. This is will help us to create the instance, and then we can say using count. This name you can give anything, is not really reflected in your AWS resource, it's just for the script purpose. Now you can define count. I want to deploy 3 instance, and then AMI ID. AMI ID is more like let's say AMI ID 1 2 3 4 5 6 7, but technically this AMI is not exist. So what we can do is, let's open the notepad, and then in the notepad we have this AMI. We can get the AMI from the data source. Okay, you do not you do not really need to looking for this AMI from the data source. You can get it from the AMI ID, but we just want to be make sure that this can be populated automatically. So we can say data, and in the AWS AMI, and we supposed to be have AMI, and then we can say we want to fetch it Ubuntu, and we can say most recent equal to true. That's fine. And now we have to filter this AMI, so we can give name equal to name, and then we can say values. Then in the value we can give our string that we have copied, that we want this one, and then we have another filter that will give like name equal to virtualization type, and in the virtualization type I can put the value that is hvm. Okay, and then we can have owner. The owner we can of course copy it from network. That's this owner should be creating the AMI. That's okay. Now let's get the AMI name from the data.aws ami.id. We're supposed to be have a data, and then we have a data.aws ubuntu.id. This way we can get the ID, and then instance type. We can specify instance type T2 micro. Okay, and now let's say tag, and we can see inside the tag we have a name equal to using count plus and we are in the string, so we can also do like dollar count dot index. So this index start from 0 to 3, something like that. Okay, so you can save it, we can check the readme file, so we have something like, okay, EMI ID T2 micro and index, that's perfectly fine. Now let's do one thing. We can run the Terraform client and see Terraform command and see whether we have 3 instances planned or not. Okay, we are not gonna creating the instance because this is just for the demo purpose. If the plan results show 3 instances, then we are good enough. Okay, so let's do initially we can run Terraform init command to initialize the backend, downloading the provider that we have specified, and according to our specification in the script, we are going to download the HashiCorp AWS provider version 5.100.0. This version is nothing but the latest version for the Windows machine, and we are using a Windows machine. This Terraform init command you have to run when you are working on the fresh project. Okay, so I always suggest whenever you have a small requirement or a big requirement, go from the scratch. So this will, as a fresher, as a beginner, this will help a lot to get familiar with the things. Okay, so our Terraform init command has been executed successfully. Now let's say we can run Terraform plan. So this supposed to be create at least 3 instances, and we got an errors. That's correct. Let's say count. Okay, there was a typo mistakes here. We do not have L here. I believe the typo mistakes. So let's go back again and run the Terraform plan again, and this time it will take a look, read our script, and script looking fine. So we get another error, and probably is saying the filter name is invalid. Really, the filter name is really invalid. So let's checking the filter name, which name, this name, we have a name and it's getting the error, name is invalid. And at which line? Is saying line 14. So it's saying line 14, so probably you will have a error is here on the name. So that's why name is not, so it's like name. This one we can try. If this problem we can, and if you have like such kind of the problems, so it's always be great that you can refer the okay, this time name is okay, but it's saying filter virtualization type is invalid. So if you getting such kind of the error, there is a possibility when you are writing a script, right, something you do not aware. So just type the Google like, okay, I'm getting this error, then it's saying like, okay, and probably getting reading even unauthorized operation, not this one, then easy to describe virtualization type is incorrect. Virtualization, probably we have a spelling mistake, I believe here. So or maybe you can let's say what's the type virtualization. We can check the spelling name here by pasting the copy virtualization test type HVM. I think type is correct. So let's say we can copy this and try on the Google, just because as a fresher you can, let's say, working on this, and then we can get this code here, data AMI from the Terraform itself. So now you can see we have a filter names and value virtualization time. What we can do is, I believe, looks like what's the problem, we write in the same format, right? It's supposed to be have the correct format, but it's not getting the correct. So we can check it out, like, oh, we write the V capital, it's supposed not to be the V capital. So this kind of the type of mistake will be happen when you are writing a code by just remembering. So remember one thing, do not remember anything of your script, but try to understand the logic. Okay, the moment you understand the logic, you are good enough to go. Okay, Terraform has a huge library and you cannot remember everything. Okay, huge types, like there are a lot of things you have to, but you cannot remember. So always go and refer the documentation. So now let's try to run Terraform plan again, and this time probably we have fixed the problem. So this is always, always great when you see any error, that you are see the error and trying to fixing the error. That is like in a real world when you are start working. Okay, so let's say we are trying to deploying 3 instance, and here it's showing the 3, so we are good enough that count loop is working. Okay, so now let's move on the second loop. We have for each. In the for each, you can retrieve the object, for example, right? So for example, it's more flexible than count because it will give you like a object with the key value form, so you can assign different value to the different types, right? For example, let's say we want to create an instance, probably 2 instance, one for the dev, another for the production. So we can go for this example. Now let's go to our main script, and we can comment it out over count part, and we can write it down this script. Okay, so this is a great, and let's comment here for each. Fine. Now, but the code looks like it's not in the format, so we can do one thing. Terraform fmt command. This command will help you to format your code, and the one file has been formatted. By default, this command looking format all the file from the current directory. So now the file has been formatted, and it looks still not that good, but it's still good. Okay, so now let's say we have this code. So what we are doing, we are putting a for each command, okay, for each loop, and we assign a one object to that loop, and then we have an AMI ID, and then we have an instance type, and we will retrieve the value from the each from the each element, right, that we have in the object. So how we can retrieve the value? So you can say each value, that means this is the value and this is the key. So if you want to retrieve the key, then you have to retrieve the key value like this. So let's try to run the plan command again to see what we are going to get in here. Okay, that's fine. So we can say terraform plan, and this time we are going to create 2 instances, so it's supposed to be have 2 resource to add, but it's adding 3. And why is 3? Just because we forget to save our file. So the new code is override, and we will save it. Okay, so this is how we can save the file, and then let's say plan it again. This time it will be create the two resource to add. So something like we have already mentioned that we have day one prod environment, and we will successfully plan for 2 resource. Okay, now let's move to the next loop, or more like a expression, probably the next, like okay, we will look the for expression later on, the for when we are discussing the expression. And the next one is a dynamic block. Dynamic block is very important. It's more like it's working in a different way that you are thinking. So for example, let's say that you want to getting the value from you are creating one variables and define a array of object, and in that we have a port protocol, something like that. Okay, and you want to retrieve this list by using the dynamic block. So let's say you create one AWS resource. Okay, that's fine, and then you adding the dynamic block here. You give the block name ingress, and inside the block you have for each, and then you assign the var.ingress rules. So at the time when the loop is start, one object get initialized in the loop, and then you can getting the value because you are using the object, right? So you can accessing with the name, so you can go for like port ingress and then value and then port. Okay, yeah, you can assign this one something like that. So this way you can creating a multiple stores, and then we have a content here on the ingress book. So let's try this scenario and see what we can do here. So before we can try in the main, so let me comment it out this one, and then since we are creating the security group here, right, security group related this resource, we have to create a VPC. So for the VPC we can have a data block that we can say AWS VPC, that's fine, and we will get the default one, default, let's say default, and here we can say default equal to true. So this will give us a default VPC in the current region. So now let's paste our code. So here we have declared one variables, that's fine, and then we are declaring a resource. In the resource name example SV service example, and VPC ID we can go to like here data.vpc default.id. This way it will be get the existing VPC, and then we have a ingress dynamic block, and here is our object variable that we are assigned to for each, and we have a contain, and in this contain it will be getting port from the ingress value port and this one. So let's try to run the Terraform plan to see how many resources it allocate. We are expecting 3 resources here. Wow, what's the results here? It's saying Terraform has compared your real against your configuration and found no. Okay, we forget this save again. So let's save the file and try again. We can go for the Terraform plan now. Okay, it's reading default VPC and then fetching the AMI, and it's saying we are going to run one to add. One to add is okay, that is will be going to, so now you can see here we are going to add one security group. Inside the security group you can see here we have ingress, so we have an ingress of port 2020 22 and port 443 and port 80. So in this way you can make sure that we have used a dynamic block to at least generating 3 set of the ingress port. So this dynamic block is really very helpful when you are repeating nested block. So go for the dynamic block if you have such an environment. For example, if you are working in a company and your company wanted to expose multiple ports, so either you can configure them manually by writing block by block, or you can go for the dynamic block that can generate the nested block. So that's all for the loops. So now let's go and check our expression. Okay, So expression, as we can see here, like we have many type of expressions. You can also have like a reference variables and resource. So simply you are giving this, right? So string interpolation, it means like you can combine the strings and generate something, right? For example, in the previous example we have seen, let me put it in the split on the right side. So in the previous example you can see we have do the string interpolation here, right? So this way, this is one expression. Second one, we can also generate the ternary command. For example, let's comment line this and we can see use of ternary. So we can say variable, okay, and in the variable you can define a variable env, for example, as we suggested, and then is saying type is object, and then we can say or we can simply keep the value string. Okay, string is okay, we just, and default is prod, right? Let's say default equal to they, not the prod. Okay, prod is we can explicitly specify from the command line argument. And now let's do one thing. We have to create the instance for our different environment. So let's say resource, and we can say AWS instance, and in this you can do one thing. You can give my instance name, then you can AMI ID, you can fetch it from data ubuntu.id, that's okay. And the instance type, okay, because in the day we want to different type of instance, and prod is different. So what we can see, we have instance and we can say this type should be get it from environment variable, and if environment variable value is prod or let's say dev, then we can have a true value, we can assign t2 micro, okay, or else we can go for t2 large, okay, typo mistake, t2 large. So this is the way how we can create using a ternary expression or conditional expression. So now let's run this Terraform plan, and then if there is no error, then you will see um, one resource is added, of course, because we are creating one instance, but we have to see the type of instance here. So you can see t2 micro because it's a dev environment type, right? So let's say var and env equal to prod. Trying, I'm not sure how to, you can use the command line environment variables. So want to add now, and then it's a t2 large. So that means we are passing a value from the command line and saying that our environment is not dev, but we going to deploy this instance in the prod environment, and we have set up the condition that if the environment is the prod, go for the t2 large. Okay, so this is about the conditional expression, right? And why not we can view it in a such a way that we can look at it pretty, right? So now it looks much prettier than before, right? So okay, so now we have a for expression. This is very important expression, you can see here that we have exist. So here what we can do is we are getting the result from our for expressions, okay, and we want to print out the output. For example, let's say we can say that you have a variable called names, okay, and this is a list of variables where you can specify the strings. You specify the strings, and then you can, now let's give the default value here, and we can give the default value, what we can give, dev, let's say QA, and let's say prod. Okay, now we give the value here, that's fine. Now what we can do, we will we will change the small letter to the capital, so we will, putting the string upper later. So in the output you can say names again, and then you can specify the value. In the value you can say 4, and I'm getting name from names, but that's supposed to be var dot names. Okay, we are getting this value. Okay, and now you getting this value, that's great. And then you can, after getting the value, I running the function called upper, and I'm give the name here. That's name supposed to not to be the name, but your n. So now when you are running this, so all these three value turn a small string turn to the capital one. So let's run Terraform plan. We can remove the environment variables, and we have run Terraform plans, so it will print it out dev QA and prod in the capital as it's shown in the string. So this is how you can use the for expression when you want, right? And there is also, like, you can, inside the for expression you can also putting the condition with the filter, right? So for example, let's say in another output we can say names with filter, for example, names with filter. So what I'm saying is, okay, I want to run the upper function, but only I want to run the upper function, but only when n is not a QA. Okay, so let's say I'm saying upper is keep here, and then I'm saying if n not equal to QA, except the QA, do everything upper. So let's try to see in running the command. These expressions are very handy when you are working on the real project and you are, getting the value from the conditions. So now you can see our first name printing out all the value, all the names turn change to the capital one, and in the second with the filter we exclude the QA, and the rest two will be, capital. So this is the way you can deal with it. Now let's talk about the splat expression. A splat expression is nothing but sometime you may encounter when you have a multiple IDs. Okay, multiple IDs. So it will be helpful to, handle those multiple IDs. Especially you have a security group. Let's say you have multiple security group, or most probably you have a multiple subnets, right? So you can also using the resource, something like putting the star in the bracket, that whenever you want to get the all the subnet, public subnet, then you can, putting the star and dot id. So this way you can, creating the splat expression. Now let's talk about the Terraform function. There are many Terraform function exist. We have a upper function that can be, change your string lower to upper, and then similar way we have lower function that can help you to change the uppercase into the lower one. And you can also use the replace function for the string if you want to making the first character capital, and then you can also join to string from the list. This is very handy when you are preparing some string manipulation, and then split. If you want to split a string into a list, then you can also using the split function by providing a comma as a separator. Similar way, we have a numeric function. There are plenty. We are not gonna talk about these functions here, and I mentioned if you want to refer the specific function, go for the document of Terraform, which can help you to list out all the function. So you can see here we have the functions, and also we discuss few expression. There are many. You can go for here types and value, so you can see all the things. For expression, here we have similar way. In the for expression, we have a split expression, as you can see, list star.id, so you can go with that. Dynamic blocks, we have, I think we discussed the dynamic blocks like this, okay. And version constraints, I'm not sure, but it will something like operator version. Yeah, that's also, we have a version constraint. So you can I encourage you to read the Terraform official documentation for the expression that are not commonly used. And a similar way, in the function you can find all types of function like numeric, string, collection, encoding, file system function, date and time, hash and crypto, IP network function. Most of the time IP network function are useful to getting the cider subnets and cider host, cider net mask. You can go for these kind of the function that will bring a handy functionality that can execute without no time, okay, with no time. So something like that. So that's all for this video, and I hope you like this video. And if you have any suggestion, any comment, write it down in the comment, and I will make sure that you will get this readme file and you will get this code in my Git repository. I will mention the Git URL in the description. Apart from that, I will also mention the reference documentation of Terraform. So that's all for this video, and see you in the next video. Thank you for watching. Have a great day, enjoy, and happy learning.